Hello, and you are listening to Eco Justice Radio. We present environmental and climate stories from a social justice frame featuring voices not necessarily heard on mainstream media. Eco Justice Radio acknowledges we recorded this show on the traditional territory of the Tongva people and all of their relatives in the place we call Los Angeles. Welcome, I am Jack Ide. On today's show, Building Resilience, Fire-Resistant Design for a Safer Future. We feature an interview with ecological architect Carl Welty. Carl Welty has over 35 years of experience in the field of architecture and is based in Southern California. Carl has designed complex projects working on sensitive or difficult sites. He's known for his passive solar house design and a water education campus that embodies regenerative approaches to sun and water flow. He designs buildings that are twice as energy efficient as typical green architecture by incorporating simple, time-tested, climate-appropriate design principles. In this episode, we welcome back architect Carl Welty to discuss fire-resistant design, construction, and alternative materials. With, the increasing threat of wildfires, Carl shares his insights on regenerative design and the importance of working with nature to create resilient communities. He highlights the innovative Village Homes project from the 70s in Davis, California, which serves as a model for integrating healthy soil and passive solar principles into building design. He further encourages listeners to consider alternative materials such as steel framing, which offers advantages over traditional wood or mass timber, which is being talked about quite a bit these days. And he's debunking that concept. He gives us a lot to think about out in the world in terms of durability, fire resistance, and environmental and carbon footprint. Ultimately, today's show serves as a call to action for architects, builders, homeowners alike to rethink their approach to construction. By embracing regenerative design and prioritizing the health of our ecosystems, we can create communities that are not only safer, but also more sustainable in the long run. Well, I'd like to welcome Carl Welty to Eco Justice Radio. Carl appeared on the show. Actually, I think it was a couple years ago. We were talking about your work and my work. We've worked together on a bunch of different projects. Your view on regenerative design, if you look into our podcast list, I think it was 2023. We had a great conversation, an episode that won the award, Outdoor Writers Association of California. So Carl has a good track record with us. So today we're going to talk about fire-resistant construction and alternative materials, alternative design. Put a lot of effort into understanding, critiquing the way they're building buildings. Because, look, we lost more, what was it, 12,000, 13,000? I don't know how many structures were lost in the Los Angeles area last month. We really need to consider alternatives. So first, I want to start with you, Carl. Your approach to design, and like I said, we've talked before, but I think you should update us and people how you approach design and materials, and what is your reason for being in this design, as an architect?
I'm an architect because I can't help myself. Yes. Too inspired by architecture and too dumb to do anything else. But thanks, Jack. Great to always have a conversation with you. To this very difficult questions about how we as a species move forward in after these fires, and as an update on where my head's at, I've become more convinced or a passionate advocate for what's called the biotic pump, or another, the thing that's missing so much in the way we're thinking about communities and our global climate is doing things that build healthy, moist soil, both in our neighborhoods but also regionally or globally.
That's pretty strict. Don't usually think about soil. Aren't you supposed to be thinking about the building, Carl?
Well, don't tell anybody that.
No, we should tell everyone about it
I know.
because I think
Yes,
you're
I
making a
agree.
good point.
So my passion for it's the soil comes from thinking about the question of creating landscape that is less flammable, which led me to starting to look more deeply into a development that's in Davis, California, which I believe, and Jeff Lawton from the Permaculture Institute believe it's one of the greenest projects in the world. Jeff Lawton thinks it should be a World Heritage Site. So I invite anybody who are curious and looking for ways to do things differently. There's a really now a 50-year-old example of how to think differently. And then, by the way, because it's now 50 years old, it certainly has passed the test of resiliency. And
Those
so,
village homes in Davis, California. Is that
yes, if one Googles Village Homes, Davis, California, America's Forgotten Food Forest, it's a 15-minute video from Jeff Lawton from the Permaculture Institute. Well, I just said so back to the fire. I started looking at it more deeply because I understood how it worked, and and it was designed to capture the water, the storm water, and so it's a simple idea of capturing water, more moisture, healthier soil, trees that are less flammable. But what I really have learned is it's really an extraordinary example of nature-based solutions or designing in partnership with nature.
yes.
And the example of my mantra is work with nature. It's always more energy efficient, resource efficient, more cost effective, and more resilient, more durable. And so it's called a food forest because when the designers slash developers, the Michael and Judy Corbett, who are still around, when they designed it to capture water. And they were doing this in the early 70s. What's that, 30 or 40 years before California mandated retention basins and holding water back on the site. California started requiring holding back water on the site in 2010. So they're of an era when water was just another resource that was wasted and get off the property as fast as possible. But they designed the landscape or the grading to collect and capture that water. And one of the things that makes it a really beautiful example of working with nature is by working with natural flow and surface, they were able to save $200,000 because they didn't have to buy concrete drain pipes. And drain pipes to me represent infrastructure that we have to put under our cities to make things work when we don't design with nature. So they saved $200,000 because they on concrete drain pipes, and they bought 300 fruit trees. So now instead of having concrete drain pipes underground, they had the fruit trees that obviously produce fruit, but
So that's the food forest.
that's the food forest. So
Yes.
the cycle is so you have even in a hard clay soil like Davis, the trees gets a little bit of water that's a little bit deeper, and the roots go deeper, which breaks up the soil. It allows the water to penetrate deeper and deeper and deeper. And now I sort of imagine this huge ball of wet soil under the community, and it not only makes the trees healthier and moisture, which will reduce the flammability, and this is why it is absolutely a model for what we can do, is that because that big ball of wet moisture, the soil, in conjunction with the trees, we have to think about trees, not trees and dirt, but trees and soils are the same thing, same system. So the result is that the microclimate in the 60-acre development is 10 to 15 degrees cooler than the rest of Davis, and
Wow.
people live in their well-designed passive solar homes through the hot summer without air conditioning. And just challenge anybody to tell me one thing about one development or one solution that achieves that kind of result.
Davis, California is in the Sacramento area valley there, and it's a warm place.
It's a warm place.
Yes. In the summer mainly, but even, much of the year. One thing you did touch on, but it's sort of an expertise that you have. Let's talk a little bit about your passive solar. I mean, we're going to get into fire resistant, but I think because you're a big focus of your viewpoint comes from passive solar orientation and building energy performance.
So I'll try to connect that to fire also. So passive solar is again principles that some heroic, smart people from the 70s rediscovered, including a professor of mine at San Obispo. It's working with nature. So you orient a building to the south, and you work with the basic things that nature or God, whoever you want to think, gives us, which is the sun is lower in the winter and higher in the summer. You put most of your windows on the south side to allow heat to come into the building in the winter, but the roof overhang keeps it out in the summer, so you reduce the heat gain. You combine that with venting at night, which is what makes these houses in Davis, even in addition to the landscape, enables them to live without air conditioning, is that the house is cooled off at night. So this passive solar principles can typically produce buildings that are at least 50% better than are more complicated, more expensive technical buildings that rely on technology, and achieve these results without increasing construction costs. So it's really pertinent to environmental justice, that we can make affordable housing that incorporates these principles. So for me, designing buildings, passive solar buildings that provide thermal comfort without any energy input, it should be an important component of environmental justice. Yeah. And the ecological benefit, house, a structure that's providing most of the thermal comfort without any energy input. The energy system is built into the envelope instead of solar panels on the roof. But so a building that is using less imported energy or less machines that requires importing technologies is a way of reducing our global impact on oil fields or coal fields, or in this case, to the fire. We can think more globally about the resources that we're taking from other places to build our communities. So for me, the same principle of designing a community like Davis, that we can capture that water and create a less flammable landscape that can help cool our neighborhoods and our cities and our planet. It also, the same principle can be used to better manage our timberlands, where we get our wood, to help cool the planet. So I think that the beauty of this thinking is that, with nature, when you work with nature, solutions fall out of the process instead of the normal technology-based looking for solutions. They end up being band-aids that solve one problem at a time, but almost always produces multiple problems that need to be solved by another problem, by another solution.
Yeah.
And I can share some examples of that, but
well, we can jump into that, but so we've been talking about wildfire. You've thrown out some examples from history of places neighborhood wide, and we're going to want to get into how to rebuild, in neighborhoods that are existing, as well as, new neighborhoods that might be planned. But so just let's talk about fire resistant construction, just the fundamentals. Because we've got a building code and correct me if I'm wrong, they're updating it, if not every year, every 3 years, something like that. And they're trying to cover some of these things. We've learned a lot from fires in recent areas in California, in Australia, in Maui, other places. But is the building code manifesting that? And what do we need to do about that? Before you go into the code, just go into the.
Let me just summarize village homes one more time.
Sure.
And so the brilliance of the simplicity of their planning is by taking the water that comes to Davis in the wintertime and harnessing and capturing it and growing a food forest. So it's an example of working with nature. You solve multiple problems. And then the two big problems that it solves is the trees are healthier, they're less flammable, and it also helps reduce the amount of energy required to provide thermal comfort. So these people are living without air conditioning. So in the rebuilding, we have an opportunity to leverage this moisture to make our communities less flammable, and also use less energy. So that's just so anyway, I just wanted to, it's a really beautiful example of how efficient nature can be if we work with it. Anyway, so thank you for letting me sort of reemphasize that.
Great.
So to the code and alternative materials, maybe so I like to consider myself an expert on alternative materials, alternative systems. And it's hard earned because in 2000, now 25 years ago, working on 2 projects in the LA area, I came to the conclusion that the wood we build with today isn't worth building with today.
Yeah.
And that question has led me on a journey of using some various alternative systems and researching more. And
I mean, the termites would definitely disagree with you. I mean, they think
well,
that wood is just fine.
But we want to build for, they have enough wood somewhere else. But actually, one of the lessons I learned with, finishing a project, and my client's exterminator advised them to put a tent over the house for termites. And because I hadn't, so my first reaction was, well, that's crazy. This all new wood. And the exterminator was ahead of the curve, and he said, well, the new lumber, it brings termites into the house.
Interesting. Yes.
And being, zooming out to the big picture. So one of the things I've learned from over these years is that the reason why termites love this new lumber is also why it burns faster. For me, the connection between this lesson about termites is connected to a newfound passion, which is the problem with the way we grow wood. So we can talk about this more, but what I realize is that we have been convinced by the lumber industry that our lumber comes from nature and that it's renewable, et cetera, et cetera. But the reality is the lumber comes from monocrop tree farms. And like every other monocrop agricultural product, it degrades the soil back to the benefit of moist, healthy soil to help cool the planet. And like the bad carrots that we grow or all the other produce that we use that has less nutrition, the trees grown on these monocrop tree farms, it's just fast food. It's a lower quality. So that low quality, less dense lumber will burn faster, and the termites like it a lot more because it's easy to eat. So that's the closing the loop on that one.
So let's talk about, and we can get more into the details of wood construction and its limitations, but I want to continue just in the big picture of fire resistant construction. I mean, there's this concept of rating in terms of hours in the building code. Fire resistant, what rated 1 hour, 2 hour, does that mean like it can burn for 4 hours and you'll be safe? Is that what a 4 hour?
Basically, yes. And so the way the building code works, and I like, as an architect, the building code is the rule book, the Bible, if you will. And there's great simplicity staying within the building code. And I'm not disagreeing with people that think that the idea that it could be upgraded, and yes, could be upgraded. But so the way we architects talk about fire rating, it's 1 to 4 hours. So or non-rated. So the normal house that most of us grew up in houses that are not in a fire area, it's non-rated. But one of the basic requirements of the new fire code that started in 2008 in California is that the exterior walls have to be 1 hour rated. Which fundamentally that means you put a layer of special fire-resistant, heat-resistant drywall on the outside and the inside of the wall, and that gives you a 1 hour fire rating.
And so that's only in areas in high fire zones, because there are maps that what you're saying.
Yes.
Okay. Well, listen, we're gonna take a quick break here and get back to talking building code with Carl Welty. So be right back. You're listening to Eco Justice Radio, a listener-supported media outlet. Please consider making a donation to ensure that we continue to provide socially and environmentally driven content. Donations can be made at ecojusticeradio.org or SoCal350.org. For an extended version of this interview, as well as other benefits, We encourage you to become a member of our Patreon at patreon.com/EcoJustice Radio. Today you're listening to Building Resilience, Fire-Resistant Design for a Safer Future. I'm your host, Jack Ide, and we feature an interview with ecological architect Carl Welty. So we're back with Carl Welty, and he's talking about fire-resistant construction. We're talking about rating of walls, and the theory of a 2008 building code change. So why did they suddenly introduce a rating when most of us, as you say, grew up in houses that were non-rated, meaning they're more burnable? Is that kind of what we're talking about?
And I don't know when this happened, but the houses that were probably the 60s. So the house I grew up in as a kid, which is in Vacaville near Davis, but that's, the only the wall between the garage and the house was a 1 hour rated wall, because usually the fires started in the garage, and so we would make a wall that was slowed the heat transfer from one side to the other. Now, and I think this is an important discussion or topic for people who are not architects, because this is the basis of when we talk about new codes or changes of materials, it's always going to be about 1 hour to the hour rating. And so the building, the California the WUI code requires a 1 hour wall, and there's some upgrades in windows and some other parts, but the big part of it is the wall.
And that's Wildland Urban Interface Code.
Yes. So there's other parts, there's other requirements in buildings that require a wall to be 2 hours. And so a building that I have learned about, a 4-story hotel that was lost in the wildfires in Colorado in 2021, the fire was such that it ignited a 4-story hotel that without the walls were 1 hour, yet it still ignited. But the stair towers, which the code tells you has to be 2 hour, so the stair towers survived because they had a higher fire rating. So that just to me is an example of the extra fire protection worked.
Yeah.
So again, the rating goes from 0, no rating, to 1 hour, 2 hour, 3 hour, 4 hour. So a concrete wall is a 4-hour wall. Obviously, a concrete wall, it's going to withstand more heat than a wood wall, regard.
Yeah, they certainly absorb a lot of heat too, which is
and some people suggest, well, we should just build houses with concrete, which is a lot more expensive, higher carbon footprint.
It's not breathable, very hot in hot climates, although they do stay cool too in places.
Well, we can circle back to the passive solar. It's the energy performance if the walls were only concrete is not very good.
Right.
And the building code tells you, if you wanted to build a house, a 4-hour wall with concrete, you're going to have to put a second wall inside with wood framing or something that adds more insulation. So the concrete walls is not going to provide the insulation requirement. That's it. So for me, as in thinking about how, within the code, the way the code tells us to build, one question now that everybody here who's listening to this are an expert on, you can have up to 1 to 4 hour wall assembly. So the code tells you that if you put 2 layers of this fire rated drywall on the outside and on the inside of the wall, even if a wood framed wall, that now wall is a 2-hour wall, much like the stair towers that survive the burning of that hotel. So I'm doing this now. So I would like to put into the conversation, what if as a recommendation that somebody could make the choice to double the fire rating. And just as an example of how simple it could be, on a 2,500 square foot house, you would probably add less than 1% of the overall construction cost. And by
doubling
the drywall,
the
wallboard. And nothing is fireproof, but from experience, and we know, like that building in Colorado, that 2-hour wall is going to have a much better chance of surviving than the 1-hour wall.
Right.
Because the hotel's 1-hour walls were lost. So a difference between wood and steel is the code the code tells you with wood, you can put 2 layers on both inside and outside, and you have a 2-hour wall. But if you put 3 layers of drywall on a wood frame building, it's still a 2-hour wall. The code doesn't let you keep adding the hours to a wood frame wall. But with a light gauge steel frame wall, you can put up to 4 layers on that wall, and you now have a 4-hour firewall. So
Why is that? Is it
with
because of the difference between the wood and the steel?
yeah, it's clearly because the steel is non-combustible.
Right.
So
So,
there's
meaning after 2 hours, that wood is going to go down,
by all the
even,
testing is
even if
yeah.
it's protected by wallboard.
Yeah. So the rating is it's, and I don't know the exact figures, but it's about how fast the heat goes through, penetrates this wallboard. So if you have 4 layers, it's going to penetrate. It takes more time to penetrate. And on the in the realm of talking about examples, because I like real world examples, 500 feet from that hotel that was totally lost, except for the 2-hour assembly on the top of the stair towers, was a Tesla service center, which was framed with steel. And I have pictures of it burning. So there was wood siding on the outside, which probably was ignited by the embers from flying from the hotel and the other 900 houses that were lost. So the building caught fire. And to me, this is a really powerful example because we're not talking about, why did that house burn and not that house? This is an example of the building caught fire and it didn't burn down. And so there's a value of looking at that. So what makes the building that catch
The Tesla Center.
the Tesla Center? And what I know because I talked to the building official in a call, the after the fire, the building they had to remove all the siding, all the finishes, and they just refinished it. So the structure was not damaged by the fire, and maybe more importantly, because the structure was not combustible, it didn't add to the fuel load that would spread to other buildings. So what happens with our communities once this the firestorm is when one house burns another house, the fuel load is the wood framing.
Other requirements in the state wildland. I just want to make sure people and this wonky term wildland urban interface. It's right at the edge where all these fires start. If you look at where the fire started, Eaton Canyon, right next to a lovely park there called Eaton Canyon, right on the edge was where that Altadena neighborhood was, some electrical infrastructure, it seems at this point. And up in the Palisades fire, up in Palisades Highland is a pretty wild place surrounded by Topanga State Park. How that fire started was probably by, some people playing around and however that was. I'm not sure exactly how it started, but it started at the edge. So that's the wildland urban interface. And if we can stop those fires from igniting the homes and starting to burn the neighborhood, then we can stop it from moving in and taking out the entire, community. So that's the concept of making the edge of the neighborhoods more fire safe. And so there's a number of other requirements that they had. Can you tell us about those?
Yeah, I think in the list of vulnerabilities, and I just saw this in trying to investigate these questions more. So supposedly, they estimate 90% of the homes that are lost in these large community fires, the houses are ignited by ember storms penetrating into the attic vent, the roof vent, or the floor vent. And so one of the new requirements is that the screen that protects that in these openings, it has a 1/8 inch squares instead of a 1/4 inch square. So that's a very big deal. And there's other requirements of not having no flammable or combustible materials on the outside, no wood siding unless it's treated, and some upgrades in the window treatment. The windows it has to be tempered glass.
If they're refitting the ones that have big vents.
Yes, if they're in a new house, the vents will be covered with or protected with a smaller wire screen.
So more other things.
That's the kind of the big picture in the code, and I there's the other important issues that are part of the creating defensible space is restricting the amount of flammable gates, decks, and some of the landscape in your own yard. So those sort of the kind of the big picture issues.
A lot of people blame the trees around their house, but frankly, so defensible space would include, because if you look at a lot of these houses that are built, there's that have burned, there's trees that aren't burned, green, because it's green wood and it doesn't go up. So if your trees are properly trimmed, there's also the concept of not creating a fuel ladder. So there are some trees that are more flammable than others, but in generally speaking, as long as they're not connecting to the house, and making sure they're trimmed off the house and cutting all the dead, and that's a whole much broader conversation that we can have in others. But I think it's good to say 100 feet of defensible space, no wood decks, siding, different stuff like that.
100 feet, 100 feet is a lot of space. But also I'd like to make a point, another lesson from Paradise Fire. There's a really dramatic picture of the pine forest, the trees, they're all still there, and all the houses in the neighborhood are gone. And so in some paper from Paradise Fire, somebody makes a point that it wasn't a forest fire that burnt down houses.
Yeah.
It was the fire was the houses were the fuel load.
I know, and there's people who say, well, they must have used direct energy weapons that took out because those trees weren't burned. Well, we could argue that the direct energy weapons are the fossil fuel companies, but that's another issue.
But also adding to the so we know that supposedly 90% of the houses are ignited by ember storms,
right.
which those embers fly miles, so but the other cause is structures can combust when the interior air temperature exceeds 500 degrees.
Interesting.
And another lesson from the Paradise Fire, which I think is a really important thing to mention, is that some people went so this is to the point of why we need better codes, and I think why we should stop building with wood completely is that 40% of the houses in Paradise that were built after 2008, so they were built to that 2008 WUI code, were lost. So I don't think a 60% survival rate is good enough. I think particularly if we know that there's things you can do to increase that chance. But this other house, I think provides some really great insight. So the couple came back to their new house, relatively new house. It was still there. They go inside, and this horrible smell of charred wood. So what I know from knowing and reading into this, so the air temperature in the house, all of the windows were still there, so the envelope was not damaged by the fire, but still the interior temperature was such that the walls of the wood studs in the interior walls were hot enough to start charring. And they make a point that it was the interior walls and not the exterior walls. So the exterior wall, so that seems to fit in with what we know about the code, because that exterior walls have that special the wall board on both sides. So even if the temperature was between 400 and 500 degrees inside, it would not char the exterior walls because it's protected with a 1 hour enclosure. So those people, they had to spend $300,000 to replace the wood framing on the interior walls. So to me, this is a really great example of another way houses will ignite is from radiant heat, and that requires the trees to be, whatever is burning close enough to raise that temperature inside. So if the radiant temperature or the radiant heat will raise the temperature of the inside of the house, and if between 400 and 500 degrees the wood chars, above 500 degrees that wood will ignite. And so there is evidence that some houses are lost from the ignition of the wood from the high indoor temperature.
And how does the temperature get so high indoors?
Well, it will through windows.
Okay, I think primarily we haven't talked about windows, but windows are a big issue.
Yeah. So clearly in this example, the house, because it was built to the 2008 code, the windows were tempered glass. So the tempered glass was not damaged, but the heat will still go through the glass. So clearly, what I know is that some houses are ignited because of the air temperature inside from radiant heating. People can Google this, and that seems to be clear from other evidence.
So if you double up the tempered windows, which I've been hearing talking about, would that solve that problem or at least mitigate it?
Well, this could be, well, the windows have the code now requires dual pane windows, so they're already double glass.
Right.
In this particular house, if the windows were not damaged, so clearly the heat's coming through the windows, not the 1 hour wall. Maybe some of it, I don't think the heat came through the walls, because then the wood framing inside the exterior wall would be charred also. So I think the radiant heat source comes through the windows. But that would be, I'm an architect, not a, that could be tested.
You're not a fireman.
But I think the heat's coming through the windows.
Interesting.
And of course, if that house had been framed with steel, even if it was 450 degrees, that it would charred wood, that the interior walls framed with steel would have been unfazed. It would not have been charred.
So there's a question also about finishes on the exterior. The paint that's used, a lot of this stuff can make things more burnable, more flammable.
Well, the code is very clear that the code and common sense suggests not to use combustible materials like wood siding. One of the recommended products is a cement board siding or stucco, which is non-flammable. But the code's also very clear that the stucco or the cement board, that doesn't impact the fire rating. So I mean, this is overly simple, but you could have, if you had 3 inches of stucco without that wall board, it's still not a rated wall. So what's critical is you have to have the gypsum board on the inside and the outside. So that establishes the rating. The finishes would be something, non-combustible, so that doesn't ignite. Like the building in Colorado, the Tesla building that was ignited, clearly what was burning was wood siding on the outside of the wall.
So,
the building.
We're going to take a quick break here.
Okay.
We'll take a break. We'll come back to keep discussing alternatives. You're listening to Eco Justice Radio, a listener-supported media outlet. Please consider making a donation to ensure that we continue to provide socially and environmentally driven content. Donations can be made at ecojusticeradio.org or socal350.org. For an extended version of this interview, as well as other benefits, we encourage you to become a member of our Patreon at patreon.com/ecojusticeradio. Today you're listening to Building Resilience, Fire-Resistant Design for a Safer Future. I'm your host, Jack Eit, and we feature an interview with ecological architect Carl Welty. So we're back with Carl Welty. We're talking about what kind of materials are the better choice. You've sort of laid out some of the details how lumber is not the choice. We could get more detailed, but I think really I want you to talk about steel framing and what are the details? Why is it a better choice?
For me, specifically to the fire issue, the fact that it's not combustible. So if you had a neighborhood of steel homes and there was a fire, the homes would not be the fuel load. And mentioning the Tesla building in Colorado, again, I think it's a beautiful example because it's a different kind of example than like, why did that house burn and not that house? It's an example of this building caught on fire and it wasn't destroyed. And a finer point on this was obvious from the post-fire photographs is that steel framing did not have the wall board on the outside to make it a 1 hour wall. So even without that layer of heat protection, the steel framing was not damaged by the wood burning, the wood finishes, or the wood siding burning. So to me, that's an example of even without that extra board to make it a 1 hour wall, the steel framing survived the material burning on the outside of it. So the first point about steel is that it's not combustible. there's some myths out there that I think perpetrated by the other evil companies, the timber industry, that steel will melt. If your couch catches on fire, steel will melt, which is not true.
Did I see situations where steel was warped in photographs? And I was wondering about that. Is
Yeah,
that
there are some
possible?
examples, and actually, and this is the person who I've learned a lot about steel framing from was just at a house that was damaged in Malibu. The house was damaged because, against his recommendation, the builder used plywood on the subfloor. So my friend and I, we think that if you're going to build with steel, don't use any wood. Don't leave anything for termites to eat. And so instead of using the metal decking with concrete that we would recommend, they use plywood. What we know is the fire broke a large glass door, and that ignited the plywood, or it maybe was so hot inside that it wood became the plywood, it was ignited. So in that case, heat will damage steel, but it needs to be 1500 degrees or higher. A couch burning in the middle of your living room is not going to melt your steel. As we've said, as we were talking before this interview, this house that I've only seen the photographs and had a few questions to my steel friend, my friend who makes provides the steel framing. There's some really great lessons to be possibly learned, because like in this particular case, a very large glass door was completely demolished. There's not even glass on the ground. It's just gone. And also the thick plywood subfloor is completely gone. So, it's not like a campfire. You might see pieces of the wood still charred. It's just gone. So clearly that fire was hot enough to warp the floor joists in this structure. But the wall framing, oddly enough, that had some plywood on the outside of it, that plywood burned, but it wasn't hot enough to deform the steel. So we're going to be able to, we will see, maybe that how the building department determines is that some of that steel is reusable because it's not damaged. So there will be this sort of a small point of why steel is the advantage of steel has over wood is that they can actually dismantle that house, unscrew it, and then if building department, like the building department in Colorado says you can reuse it, then they'll just reassemble it with the same wall framing. But that's lessons learned that that a unique lesson from a house that was mostly framed with mostly constructed with steel, but the parts that were wood were ignited and now have to be replaced, and it was hot enough to damage the steel.
I mean, when I think of steel, I don't think of it being environmentally responsible. I think of the steel plants, the molten steel, the pollution from that. I grew up in the industrial, as a kid in industrial Midwest areas. You drive through Buffalo, you drive through Cleveland, you drive through outside of Detroit. There's a lot of steel, certain things going on that weren't good. Is that how we should look at steel today?
I don't think so. I think so. The most of the well, first of all, most of the and this is the number I just found somewhere, but the report is that as much as 90% of the steel, the structural steel, which would be both the steel that the big boy call heavy steel or the light gauge steel, 90% of that steel is recycled. So one of the reasons why I think steel is greener than wood is that it's the most heavily recycled material that we have. I know from working with the steel guy that the manufacturer or roller, the local roller, which is in Riverside, they have certification every roll of steel that they buy and make these steel joists and beams from. It's certified what's the percentage of recycled, and so the recycled steel. So the steel is typically 75 to 90% more are made of 75% recycled steel. So, but and the other aspect of that is the way we make steel, particularly recycled steel, is we're not using those big blast furnace from that you talked about that we imagine as kids. They use a furnace called electric arc furnace. So you put lots of steel in a big whatever container, and they charge it with high electric uh, pulses when it melts the steel. And so that's kind of the big picture of what steel is not as doesn't use as much energy as it used to. And I would, in defense of in the defense of why I think steel is better, or the idea of steel is better, what I know from research is that in Canada, and I get that, mining for steel ore, it's not
These
like
are
growing
issues.
it's not like growing strawberries. It this
Yeah, nothing is without impacts out here.
But so
That's
in
the harsh reality.
Canada, and I mentioned Canada because that's where I found the information, and I think that this information is not readily available for the States because our lumber industry. Anyways, so in Canada, every year, every year, the lumber industry clear cuts land that's 10 times the area of all the mines in Canada. So from that, I conclude that with some safeguards, managing the pollution and the pollution, the impact of those iron ore mines could be a lot easier than managing the secondary degradation of those forests or the landscape. So every year they're cutting down 10 times more area than the mines. And so next year it's another 10 times.
Yeah.
And this is a problem with wood that I have is that, and this is, and I say a question that not just I ask the green design industry, we're taught to believe that it sequesters carbon. And there's some really great articles that people can find that suggest otherwise.
Interesting.
And I can share this article and you can post it, but there's a great article, green wood is not the green material that we think it is. But so this idea that the wood, the two by four you get is green because it has sequestered a certain amount of carbon. I think the accounting on that is skewed, and that it never takes into account that, most of the material of trees that was sequestering the carbon is left behind, or it's, that net carbon benefit is taken up by the processing of that lumber. But the other aspects is that, the clear cutting of trees pollutes rivers, reduces it eliminates, degrades the soil such that that soil is not going to contribute to the biotic pump or the potential for that land area to help cool the planet.
Interesting.
And
Yeah. Yeah, it's always interesting to look at when you're comparing things side by side because everything has impacts. As we know, electrification, solar panels, wind power, geothermal, oil and gas, coal, they all have impacts, but some are better than others, and some are others, but none are perfect. So,
so I like to try to, I might try to work to understand when we choose a material, what is the global impact? And if you build a passive solar house that is going to heat and cool itself without any energy, but that means there's going to be less need for cobalt to be mined in Africa or energy from other parts of the world.
oh, we don't have much time in our radio timed interview here, but we should maybe jump to alternative construction systems. Now, you're talking about wallboard with steel. Are there other ways? I think you're going to argue we should always use steel, no matter what some alternative construction systems might be. But how do you see? We've got Adobe, we've got blocks, earth wall construction, rammed earth, hempcrete. How do you look at these alternatives that are really gaining at least interest? Whether they're legal to adhere to the code is a question. So how does that look to you?
That's a great question. So the first point is I think that compared to these other systems, steel is a more cost-effective alternative. But I'd also suggest that steel is not the radical change from wood that we might think it is. because the constructing a house out of steel is pretty similar to building it out of wood, except that you're using a screw gun instead of a nail gun. So for me, in addition to the cost advantage of concrete or some of these other systems, these systems are limited by just kind of structural capabilities, like Adobe, for example. Adobe is really difficult to be used in an earthquake zone. It's doable, but you have to work extra hard to get, to make it survive an earthquake. And
Those old missions are made out of Adobe. How come we can't just build like they built the missions in Santa Barbara and San Juan Capistrano, etc.?
some of those failed, and the ones that are still around is because the walls are 3 feet thick.
Yeah.
But even if you went through the extraordinary efforts that using some sort of steel frame or steel rebar embedded in the Adobe, you're probably limited to 1 story. So you're not going to get 3 and 4 story Adobe buildings with any kind of affordable cost. An advantage of steel is that steel, the recipe or the design standards for steel are completely spelled out in the building code, like wood and for concrete. And so these other systems are not, and they require some special inspections or some other special provisions. Some of these systems, the code allows you to build with these materials for the individual homeowner. So it's not scalable. So this is another you know concern for these systems is we need a system that's scalable, both scalable 3 stories or 4 stories or 5 stories, but a supply chain or an industry that can build more of them faster. I had some really extraordinary direct experience building a earth-filled bag construction, which extraordinarily expensive. The earth in the bags was 15% cement, so one could not make the case that it was, you need a smaller carbon footprint than concrete. But kind of in all of these systems, in general, these systems like the Adobe, what we call high mass buildings, they can store heat, for a passive design, but you need to have insulation also. So you need to so these buildings don't perform their energy performance, thermal comfort performance is pretty low unless you do extraordinary efforts to something else to
Right.
achieve that. It doesn't. So with steel framing, it's more flexible in addition to being pretty similar to wood. So you can build a wall, a highly insulated wall without extraordinary costs. One sort of point about steel is many architects, engineers will tell you that you can't build a 2 story house with light gauge steel. This is an example of misconceptions about steel. Yet the building code in California allows you to build up to 6 stories with light gauge steel. So that's just kind of like one part of the code
Yeah.
that gets misunderstood.
Right.
But so the big in this a summary of these alternative materials, the code makes it difficult. There are some provisions for a homeowner to build with these materials, though the process of getting a permit is going to be difficult. But there's also limitations on height, availability of materials, and people to build them. And also, most of those systems are going to be limited on how high you can build.
Well, these are things we need to think about. We're coming to the end of our radio audience. Can you give us some summary and tell us how to get in touch with you?
Yeah. For me the big summary is and a recent passion is that wood is not the green thing we think it is.
Mm.
And that we have to stop buying into can I say this? Stop buying into this idea that wood is a renewable, benign resource that does not do any harm to the planet. Wood does not come from forests. It comes from monocrop tree plantations that degrade the soil, will increase the global warming. And overall, I think steel provides, even if the carbon footprint is a little more than wood, which I don't think it is, and happy to have that discussion with anybody. But the fact that a steel home is going to be good for hundreds of years as opposed to a wood house made out of the lumber we have today, long likely to survive 75 years. Yet with a steel, I could build a house with steel and the right other choices, other materials that can give you 30 plus years of maintenance-free living and also not combustible. Certainly would not have any termites. And the big picture is we need, before we even choose what material, we need to think about what can we do to rebuild our soil, to create healthy soil, to both make our landscape less flammable, but also cool the planet, which is absolutely possible because Village Homes shows that it's possible. So maybe in a nutshell, build with steel and save our forests to help cool the planet, help save our real forests, and invite people to look into this issue of and the scale of growing lumber in what we think of as forests. And people can reach me at my email address is carl.welty, welty.arch@gmail.com.
Well, Carl, thank you for all of this. We're going to continue the conversation as part of our podcast. So stay tuned for those of you who are on a podcast. But thanks for coming on today, Carl.
You're welcome, Jack. Always.
Thank you to Carl Welty. And thank you to our listeners for joining us. This has been Building Resilience, Fire-Resistant Design for a Safer Future. For an extended version of this show, become a member of our Patreon or visit our website at ecojusticeradio.org.
Please connect with us on social media at EcoJustice Radio, SoCal350, and Adventures in Waste. If you like what you've heard, you want others to be informed, subscribe and share the episodes. You have been listening to EcoJustice Radio, a project of SoCal350. Executive producer, myself, Jack Eit. Producer and co-host, Jessica Aldridge. Co-host, Carrie Kim. And engineer and original music by Blake Quake Beats. And until next time, remember, the power is yours.